Hello dear friends and welcome back to our lesson. Today we are going to cover about networks topologies. In the previous videos we looked at the introduction to networking. Also we looked at the definition of terms and several other aspects that we looked based on networking. So if you have not checked the video, please go back, check the video so that you can be able to understand what we are doing here. So today we are going to look at networks topologies. And under network topologies, we are going to look at, I think, 4 main, but in this display, you can be able to see that I have displayed 6 main topologies in networking. For example, in this case, we have bus topology, we have ring topology, we have star topology, extended star topology, then we have hierarchical topology, and we have mesh topology. So in this case, I want us to discuss each and every one of them. So the following 4 types of physical topologies are frequently used in computer networking. So we are saying we have said above that we are going to look at the 4 main topologies of networking, and under this category there is 4 main topologies that are frequently used in computer networking. So in this case we have star topology, bus topology, and ring topology, and finally we have hybrid topology. So a LAN is a high-speed connection, is a high-speed communication system designed to link computers and other data processing devices together within a small geographical area, such as work group, department, or a single floor of a multi-story building. Several LANs can also be interconnected within a building or a campus of buildings to extend connectivity. So in this case, we have seen that topologies, we have 4 physical topologies, and these topologies are connected using LAN cables. That's why we are saying a LAN is a high-speed communication system designed to link computers and other data processing devices together within a small group or a small geographical area, such as work group, department, single floor, or even a campus. So for example, you're saying that within a campus you can have these LAN cables interconnected to form a connection that has an extended connection for communication or transmission of data. So the first topology that we are going to look at is bus topology. Bus topology. A bus topology, all devices are attached to the same transmission medium. So we are saying, for example, in this bus topology, all devices that are within this topology are connected to one transmission medium. The medium has a physical beginning and end. For example, a LAN cable or a transmission cable, it has a beginning and the end of the communication. All buses are implemented using electrical cables, usually coaxial cables. So we have 2 types, we have coaxial and the other one. So we are saying that in this bus topology, it is implemented using electrical cables, usually coaxial cables, and the ends of the cable must be terminated with a terminating resistor that matches the independence of the cable. The terminating resistor prevents data reflection from coming across as data corruption. The bus is considered as a multi-point system because all devices tap into the same backbone cable. So we have seen that in bus topology, all devices are attached or are connected to one transmission medium. And here below you have said that bus is considered at a multi-point system because all devices tap into the same backbone cable. So below we continue, and an important characteristics to remember in bus topology is that all data signals are broadcast throughout the bus structure. So we are saying that in this bus topology, all data signals are broadcasted throughout the bus structure. So you don't have data being transmitted from computer A to B. No, it is transmitted from computer A to all computers, that is A, B, C, D, all the way, so that the computer that needs the data can pick it and can be able to use the information that is being transmitted. So you're saying in the following diagram, so there is a diagram that I'll display in a minute. If node B sends a signal to node C, the signal propagate for the length of cable and is seen by the nodes A and D as well. It is necessary to have an addressing mechanism so that each node understands which message is to receive and which is to ignore. So you're saying this category. So this is the diagram. We are saying that, for example, if this node B or node 2 propagates data or sends or transmits data to node 3 or node C, that now the node A and node D will be able to see the data which has been propagated. So a node can be, you can take a node as a computer, single computer. So let's take, for example, this computer 2 propagates data or transmits data to computer 3. So it means that if they are using bus topology, then computer A and computer D will be able to see this data. So node 1 is transmitting data to 3, but every other node receives the information. So that's how bus topology works. So we have seen that it is attached to one main transmission cable or main backbone cable. Then there is these nodes that are attached within that cable, and if one node transmits data, all other nodes can be able to see the data being transmitted. So what are the main benefits of bus topology? Cabling costs are minimized because of the common trunk. So in this case, you have seen that only this main cable is coming from this place up to this end, and these or other computers are attached to the same cable. That's why we are saying that cabling cost is minimized because of the common trunk. So what are also the disadvantages or the drawbacks of this topology? So difficulty to troubleshoot because no central distribution point exists. So for example, or there is no administration or point of origin that exists. So we are saying that it is troublesome, or it is difficult to troubleshoot when there is an issue. So another thing is that cable breaks can disable the entire segment because they move the required transmission from each of the two cable fragments. So for example, you say that if we break this cable at this point, then it means that the whole network will be disabled, or the network will stop working. So another thing you should note down, example of these cables that are being used is Ethernet cables, that is 10/2. So that's how bus topology works. So then the next topology is star topology. In a star topology, all stations are wired to a central wiring concentrator called a hub or a switch. So we are saying that in star topology, all stations are wired to a central wiring concentrator called a hub or a switch, or it is connected to an administration computer, which is a main one which controls the network. Similar to a bus topology, packets sent from one station to another are repeated to all ports in the hub. So it is the same as saying that all the data or information that is being transmitted from one computer to another, it is seen by all other nodes of the network. This allows all stations to see each packet sent on the network, but only the station a packet is addressed to pays attention to it. So for example, this information is broadcasted to all computers or to all nodes, but only the computer that is being addressed here is the one that sees and uses the information. Then we say the diagram illustrates, so there is a diagram that I will show below. The diagram illustrates a star topology LAN, which is a most robust topology than the bus topology. In a star topology, each station is connected to a central wiring concentrator or a hub by an individual length of a twisted pair cable. The cable is connected to the station at one end and to other port on the hub at the other. So the hub are placed in wiring closest central located in a building. So we are saying that for example, this is the star topology. We are saying that all the nodes, the nodes within this network are connected to a central hub or a concentrator. Then if information is sent from this, from node 1, it is seen by other computers as it moves to node 3. So and we have seen that this hub is placed at a central point where each and every machine can access it, or in a central building where each and every computer can be able to access the information. So advantages of star topology: we have most modern cabling systems are designed in a star physical topology. The benefits of the star topology are each device is isolated on its own cable. So if you look here, the cable is running from this computer to the hub. The cable is running from this computer to the hub. So each computer or each node is isolated to its own cable. It is reliable network and easy to modify. So we are saying that it is a reliable and easy to modify, since each and every computer is connected independently, or it is isolated. Easy to add new workstation, because you don't need to cut the cables or to do anything to the cables. You need just a new workstation and a cable to connect to the central hub. A node can fail without affecting other nodes. So for example, let's say for example this node has failed. It doesn't affect these or other nodes because there is no connection between this node and these other nodes. So the only device that fails, or the nodes that fails, is this node alone. So another advantage is that the hub or switch is slightly more expensive. So now this is an advantage, at the same time is a disadvantage, because it is slightly more expensive compared to when you are using bus topology, where you don't need any type of hub or switch. All data goes through the central point, which can be equipped with a diagnostic device that makes it easy to troubleshoot and manage the network. So in this star topology, we have seen that it is centrally located, and now the data moves through that centrally located switch, so that it can be split or it can be broadcasted, and it is easy to broadcast. Hierarchical organization allows isolation of traffic on the data. So the next thing we are looking at is the disadvantages of star topology. We have seen that because point-to-point wiring is utilized for each node, more cables is required, or because each and every computer is connected to the hub, more cables are required. Hub failure results in a shutdown of the entire network, because this hub, we have seen that it is the one that is controlling the network or the data or the information that is being transmitted. If this hub fails, it means that all network will not be working. So the next thing that we are going to look at, the fourth topology, is ring topology. Ring topology. The ring topology is a physical closed loop consisting of point-to-point links. In the diagram, you can see how each node on the ring acts as a repeater. It receives a transmission from the previous node and amplifies it before passing it on. So what we are saying is that in a ring topology, we are saying that all the computers or all the nodes are connected into a closed loop. And when, for example, data is transmitted from node 1 to all the way, it is transmitted to node 2, and then it is amplified again to minimize the loss of the information or the loss of the data that is being transmitted. It is amplified to node 3, and now it is amplified back to node 4, and we have seen this is a closed loop. So benefit of ring topology has the following advantages. Each repeater duplicates the data signal so that very little signal degradation occurs. So we have said that each app or each node or each individual computer receives the data and amplifies that signal so that very little degradation or loss of information occurs as the data is being transmitted. So it has only one advantage, but you can also try and receive, you can get other advantages. So disadvantages of ring topology, we have ring topology has the following disadvantages. A break in the ring can disable the entire network. Many ring designers incorporate extra cabling that can be switched if a primary cable fails. So for example, because it is a loop, if one cable fails, then it means that the entire network is not working or fails. Another thing is that in this case, most of the designers add an extra cable. In case one cable breaks, then the next one can be plugged in. Because each node must have the capability of functioning as a repeater, networking devices tend to be more expensive because each and every station or each and every node must amplify the information that is being sent to it. It means that this is very expensive because you need several repeaters. So lastly, we have hybrid topology. So this is a diagram of hybrid topology. In this hybrid topology, you can see we have a star topology here, we have a bus topology here, and several other types of topology. So this hybrid topology is just a combination of other simple topologies. So we say the hybrid topology scheme combines multiple topologies into one large topology. That's why you have said that if you look closely to this one, you'll realize here we have a star topology, here we have bus topology, and the other types of topologies. And we have seen that hybrid topology scheme combines multiple topologies into one large topology. The hybrid network is common in large wide area networks. Because each topology has its own strengths and weaknesses, several different types can be combined for maximum effectiveness. So if, for example, you look at bus topology, it has own strengths and weaknesses. If you look at star, it has own advantages and disadvantages. If you look at the ring, all of them, they have their own strength and weaknesses. So after combining these ones, you can be able to get a very strong. So the next thing is benefit of hybrid topology. Hybrid topology has the following advantages. One, company can combine the benefit of several different types of topologies. Work group efficiency and traffic can be optimized. Then the next one is disadvantages. Disadvantages of this one include the following. Devices on one topology cannot be placed into another topology without some hardware changes. So for example, if you are changing from bus topology to a ring topology, you must change some hardware for it to work perfectly. So thank you so much for watching. The next video we are going to look at host connectivity. If you have not watched the previous ones, please watch so that you can be able to understand whatever you are doing. Thank you so much, and let us meet in the next video.